As you can see, in this tutorial I'll teach you a method to find gnames in almost 95% games. Before I start, let me clear some point. You must know some basics of C++ and about memory address, memory structure, virtual memory, etc. Now let's begin the video. This tutorial targets only Android games that are made with Unreal Engine. Obviously you can apply the overall concept for PC games too. Keep in mind the method will only work for games that are made with Unreal Engine version 4.23 or higher. Hence it'll not work for version 4.22 or lower, and also might not work for protected games like Battlefield Mobile. Now let's discuss about what we are actually looking for. We are not looking for gnames. Now what do I mean by that? Look at the older version of the engine's code. This highlighted part of this function is the gnames, or you can say global names array. That it is, gnames word came from global names. Here the gnames actually is this names. Now look at the 4.23 or higher version's code in the same file, whole tname entry array replaced with type namepool. Now the array actually is namepool data. Yes, we are gonna find this namepool data instead of names of older versions. Look at the fnamepool data structure. We have a fname entry allocator type entries. If we look inside fname entry allocator class, we have a lot datas. The whole thing is like this: fnamepool is the outer bucket and the fname entry allocator the inner bucket, and we have some water in that inner bucket. But we can simplify it by putting all the water in a single bucket, means all datas in a single class. In this case both images is same. How's the fnamepool seems like in memory? Well, look at this example picture. As we know, one address hold only 1 byte data. That's why difference between lock and current block address is 56 byte, or you can say 56 addresses. It's 56 in case of 64-bit architecture. But here most important data that we are interested in is blocks array. This blocks array contains byte pointer. And the pointer size is different in both architecture. In 64-bit architecture pointer size is 8, and for 32-bit architecture, size is 4 byte. Each element of that array contains a different memory location, or either 0, 0 means it's a null pointer. The valid pointers always lead to a memory location where a chunk of strings or names dynamically allocated in memory. Here's comes an interesting thing. The first pointer in the array always point to a memory location where the strings start with star.none. Remember, it's not universal, but for 95% games that's how it's work. Here in this example the first element of the array contains 4000 as a value. That's nothing but a memory location. If we go to that location we'll see a large chunk of string that start with star.none. Again, the second pointer's also valid address, and it'll lead us to a different string chunk. Now here's our approach to find it in memory. We'll find the first chunk of string with its start string signature. Look at this table. If we convert these 6 characters to hex, then we'll get this 6 hex. We'll use it as a signature or AOB search. Then we'll get the chunk start address. Here suppose it's 4000. After that if we search this 4000 as a value, then it'll lead us to block start address. Here it's 1064. And here we are. We've found the structure in memory. After that, we have to subtract some bytes from this 1064 address and convert the address to offset. That is quite easy part. Let's get into the practical. For the practical I'll use Game Guardian to view memory. Take a look at this note. For use sequence of hex or bytes we have to follow some Game Guardian's rules. First we have place H ladder at the end of each hex and a semicolon in between to separate them. At the end double colon and number of hex we have in this sequence. In the memory ranges we'll select C++, alloc and anonymous. Why? Because as I said earlier the strings block are dynamically allocated. Now type or paste the sequence of bytes. In the types, select byte, because we are searching for sequence of bytes. It's optional, but you can type 1 for only first one result. Now hit New Search button. Here's our 6 bytes means the first result. To verify it's the string chunk start, let's go to the first address. And make sure in value format you've selected string representation. And here's it start with the star.none. That means this one is the chunk start address. Copy this address because we'll search this address as a value. Now delete all previous results and again select ranges. Okay, about that, we know that the name pool data only declared but not initialized and is a static data. Take a look at this Wikipedia page. It's called BSS section. So now we know the data is in BSS range, but it's just in case of normal APK. If you've installed any spilited APK, like .apks, .xapk, then Game Guardian doesn't recognize ranges properly and you might not find the data in that range. Remember that. Paste the address you've copied, and place AH in the end because it's a hex. We know that it's a pointer, and as I said earlier, the size is different. I'm in 64-bit architecture, so I'll select QWERTY because its size is 8 byte. But for 32-bit, select DWORD, its size is 4 byte. And we have one result, perfect. Now go to this address and view if it's the blocks array's first element. Oops, we have to select value formats properly. Select DWORD and hex for 32-bit, and DWORD, QWERTY, hex all three for 64-bit. You see this violet color hex, it means it's a valid pointer that pointing to the first string chunk, in other words contains the address of the string chunk start. And because that pointer size is 8 bytes, it's taking 2 whole boxes means 8 addresses. But in 32-bit architecture it'll take only single boxes. As you can see, there's a lot valid pointers. It's the current byte cursor. And it's the current block. We can go to the top of the structure that is lock, but people not do that, they usually just subtract 8 bytes from current block address, that means it's this address. Save it as whatever data type you want. Okay, let me delete the unnecessary shit quickly. I'll just rename it for better presentation. Now only thing is left to convert this address to offset. Here's the calculation in screen. For it, we have to find base address of libue4.so. Just in case if you're using splitted APKs, then it'll be not same process. Clear the previous search results, and select ranges again. This time choose C++ data and code app. In the search menu click, in all memory. Scroll down a little and tap on the arrow. Now find the first item that contains libue4.so, and tap on it. In my case it's the first one, as you can see. Yes, now copy this base address and save it to the list, where the previous one is saved. I will just rename it again for simplicity. Select both address and use GameGuardian's inbuilt feature to calculate offset. Thanks for the patience till the end.